distances between the worlds of our solar system seem incomprehensibly vast. Yet despite these great expanses, we find signs of close connections. On Earth, impact scars giving evidence to cosmic collisions are erased by erosion and plate tectonics. But some of our distant neighbors in space do a much better job of preserving details of the violent interactive history of the solar system. Billions of years of impact history are preserved in the searing terrain of Mercury. Impact craters ranging from small pits to vast basins tell us stories that range across time. On Mars, the heavily cratered ancient highlands preserve over 4 billion years of rugged impact history. But in many of the lower areas across the surface of Mars, the terrain has been smoothed, carved, and reshaped by the flow of liquid water in Mars's distant past. Much of Mars's northern hemisphere was apparently the site of an ancient ocean. There is some evidence that this ocean occupied a gigantic impact basin covering 40% of Mars's surface and resulting from a catastrophic collision in Mars's early history. Closer to home, our moon's surface exhibits basins, craters, and lava flows that stretch back across billions of years of time and tell us important stories about the history of our immediate neighborhood in the solar system. Copernicus is one of the most prominent craters on the near side of the moon. Measuring 93 kilometers across and 3.8 kilometers deep, it is a relatively fresh, well-preserved crater with spectacularly terraced walls, a cluster of central peaks, and frozen rocky ponds of impact melt on its floor. Samples returned by the Apollo 12 astronauts allowed the age of Copernicus to be pinned down to 800 million years. Impacts causing craters the size of Copernicus should be very rare events, but a recent study has found that up to 17 large lunar craters may have formed at this same time. Something very unusual and dramatic seems to have happened at that time. Researchers propose that the breakup of a large asteroid, resulting in the Eulalia family of smaller asteroids, may have suddenly bombarded the moon with quadrillions of tons of asteroidal debris. But the moon was not the only target. The Earth is an even larger target, and the researchers estimate that this shower of debris would have pummeled the Earth with an even greater number of impacts. Any impact scars here on Earth from such a bombardment would have long since been erased by erosion and plate tectonics. But some clues may still remain. The fossil record on Earth shows this massive meteoroidal shower shortly precedes the Cryogenian period. This is the time of the greatest ice ages known to have occurred on Earth. Dramatic changes in Earth's environment and significant changes to biology and the course of evolution of life on Earth. Evidence for that tremendous change here on Earth may be kept for us to read on the moon. Two particularly fascinating near-Earth asteroids may enter into the story here. Ryugu is an asteroid whose orbit crosses the Earth's. It was recently visited and sampled by Japan's Hayabusa 2 mission. Bennu, another Earth-crossing asteroid, was just visited and sampled by NASA's OSIRIS-REx mission. Both of these small asteroids may possibly be part of the Eulalia family, remnants of the catastrophic breakup of a world that bombarded the Earth and Moon. As OSIRIS-REx prepared to collect samples from Bennu, researchers noticed several very light-colored boulders that were very different from the rest of Bennu's dark native boulders. These light boulders seem to have come from elsewhere. They match the composition of rocks NASA's Dawn mission studied on the asteroid Vesta. Vesta has clearly taken a beating too. Much of the southern part of the world seems to be missing. Impacts like those that formed the Rhea Silvia and Venenia basins sprayed shards of Vesta across the solar system. Some of that debris apparently landed on Bennu. Other shattered pieces of Vesta, in the form of the Howardite, Eucrite, and Diogenite meteorites, have landed here on Earth, where today, around the world, teams are conducting analog studies in special locations that have unique terrains and environments that help prepare us and provide training for our further exploration of the Moon, Mars, and beyond. You can use NASA's Solar System Treks to explore and make comparisons between all of these worlds and more.